If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in electrical machine series. So today again we will be solving 5 questions starting from question number 151 to question number 155. Okay, then let's try to solve these 5 questions. Okay, if you come to question number 151, what is asked? The following method for an induction motor is inferior in view of the poor starting torque per ampere of the line current drawn. That means which starting current is less, that is known as inferior. So you see direct online starting, auto transformer method of starting, start delta, series inductor method of starting. So in this all the starting method, the reduced voltage direct online starting is for there is no actually starter, you are giving it online for small motor dual starter. Auto transformer start delta, you are reducing the voltage so that your I get starting torque get reduced. But same in series inductor, you are placing a series inductor. So in all these the starting torque will reduce, but where it will reduce more? It will reduce more in series inductor, because if you see the equation of the torque, what was the torque of the equation? Torque equation was 1 by 2 pi ns 3 into s e2 by r2 square s square x20 into r2, something of this format, I square r format. This is I square r, 3 I square r, this is omega into t. So at starting your S is 1, so whatever X it will impact. So if you increase your L, X will increase. So therefore your starting torque will decrease. So this is additional. In no other methods your X is changing, only E2 is reducing. So in all this method, due to this torque is reducing, but here E2 is also reducing, also this is also increasing. So both this effect will reduce torque more. So your starting torque will be more less. So that's why it is more inferior. That is, it is option C. Next, if you come to 152, a 3-phase 4-pole squirrel cage induction motor has 36 stator slot and 28 rotor slot. The number of phases in the rotor. So the number of phases that you can extend in rotor is that you can build, because rotor connection depends how many phase you want to create. So you can go up to number of slots per pole. You have to see how many slots are there. 28 rotor slots are there, and the pole is 4, so per pole it is coming 7. So the number of phase that you can build in is 7. So rotor phase you can go up to 7 phase. So that is your option C again. Next, if you come to 153, the power input of a 400 volt 15 volt 50 hertz 6 pole 3 phase induction motor running at this much rpm is 40 kilowatt. The stator losses are this, the friction and windows losses are this, the efficiency of the motor. Now in case of induction motor, you must have known the input, whatever input you give, you reduce that stator loss. Whatever power you transmit through this air gap, from that there will be rotor loss, that is S into this input. So whatever power you flow through this, the rotor loss is S into this. So that much loss will again take out. So S into this PG, suppose air gap. Now the rest is P output. Here we have assumed something, we have neglected that rotor iron loss, all this. But in a nutshell you can go in this way if it is not mentioned specifically what is that value. So generally now here you have to calculate this S. So your speed is given 975. So what is your NS? You have been given 120 F by P. So it is 1000. So it is 1000 RPM and your NR is 975. So what is your S? 1000 minus 975 divided by 1000. That is 0.025. So you got your S. So your input is now 40 kilowatt. So from that you deduct this stator loss. So it will come at 39. So 39, then 0.025 into 39. This is your rotor loss. You deduct this. This minus this will give you your output. That is 38. From that again friction and windows loss, that will also deduct. From that final output you will get this one. This is the mechanical power developed. After that these mechanical losses will come. So it is 38.025. From that again you deduct this 2 watt they have given, 2 kilowatt. So your final output is 36.025. So your efficiency will be 36.025 divided by 40 into 100, which is coming near about 90.06%. That is your option B. In question number 154, a 3-phase wound rotor induction motor is to be operated with slip energy in a constant torque mode. When it delivers an output power P0 at slip S, then theoretically the maximum power that is available for recovery at the rotor terminal. Theoretically maximum power that is available for recovery. Recovery means you want to recover it. That means how much power is lost. That you have to calculate. That you have to write in terms of P0. So you know If I take this is my output power, if I neglect that friction and induced load, then P0 will be equal to whatever input you are giving, that 1 minus S into P in. Okay. And whatever is lost in the rotor side, that we generally take is S into P in. So the power that you are available for recovery is S into P in. That much you can recover, that is lost. So S into P in, what is P in? P in is P naught by 1 minus S. So this is the power theoretically which is available for you recovery. That means that much is lost. So that is your option D. Now if you come to 155, in a 400 volt 50 Hz star connected 3-phase squirrel cage induction motor is operated from 400 volt 75 Hz supply. The torque of the motor, now the torque that the motor can provide while drawing the rated current. Current is rated. So if the current is rated, so voltage is also same 400 volts. So your input power remains same. So whenever your input power that remains same, but you have increased your frequency. Once you increase your frequency, then your speed will increase. So if your frequency is increased, that means speed will increase. And you have already seen the formula for torque. Or you can already note omega into torque is equal to B into I, that input power, and this one. There will be cause also, that power factor will also come, but that power factor is also not so much affecting. So if you increase your frequency, this is also increasing, this is also increasing. So if everything is increasing, then S is also decreasing. So ultimately your torque will decrease. So all these factors will giving one indication. This increase will also give this. Due to this speed increase or frequency increase, the reactance will increase. That will also reduce your torque. This is because you are reducing this one side. That is also will reduce your torque. So that means anyway your torque is going to reduce. You can see it in speed torque curve also, but it is quite prominent from here. So that's why it is option A. If you like the video, then press the like button and please give your valuable comments in the comment section.